Hi there. Have you ever been presented with a problem like this one right here, where it's a situation that you might never, ever, ever come across in your real life, but it could happen at some point in time? Well, this situation says the diagram below shows the amount of money that each player starts with in a video game, and they're coins and treasure chests. To be fair, each player should have the same amount of money. If each chest contains the same amount of money, how much money is in each chest, and how do you know? Well, you can go about it a couple different ways. You can try to visualize how much would be in each chest if they're the same amount, um, or you could create an equation and solve it. Well, it'll be a two-step equation and solve it. So this section is on solving two-step equations, and the learning target for it is to be able to solve two-step equations for one variable. All right. So I'm gonna give you. This is the steps for solving multi-step equations. It could be like six-step equations, but for right now, I'm just showing them to you because you'll be coming to that point in the near future. But for right now, we're not going to worry about the distributive property. We're not going to worry about any like terms. All we're going to work on is this is going to be number one, this is going to be number two, this is going to be number three. Because for two-step equations, that's really all you need to focus on, typically, is first looking for any addition or subtraction to undo. And we know how to undo it. We just use the opposite or the inverse operation. Second, look for any multiplication or division. And then finally, if there are any exponents at the end, we can use the square root to get rid of that. But really, it's PEMDAS backwards. It's the order of operations backwards, and that's kind of interesting for solving equations. Sometimes it works out that it's just the order of operations backwards. All right. So let's try that. Let's try solving a couple of these. And this may or may not be a review for you, but I've got two equations here. This one on the left is the most typical. You'll see these two-step equations a lot. So the better you are at solving them now, the more practice you get now, the easier it'll be as we go on. And it'll just come naturally for you. So make sure you're practicing lots of these. But we have 2x plus 3 equals 15. And we're trying to solve for this one variable x. Okay? So again, there is addition here. There's also multiplication because this is 2 times x. So that's multiplication. That's addition. And those are the two things we have to undo to get the x all by itself. And according to our steps, we do addition or subtraction first. All right, so we're going to undo this addition by subtracting or adding the opposite. So minus 3 from both sides, minus 3 there. We'd end up with this being nothing. So it's just 2x or 2x plus 0 equals 12. 15 minus 3 is 12. All right, done with that step. Next step is looking for any multiplication or division. Well, we have multiplication here, like we said. So we undo multiplication by dividing. Divide that whole thing by 2. Divide this whole thing by 2. What you do to one side, you must do to the other. So x is all by itself now. It's just 1x. That's what we wanted to figure out, what 1x is worth. And 12 divided by 2 is 6. So x is equal to 6. X would be worth 6. All right, the second one, similar but slightly different. We're going to still follow the same steps because there were no exponents in this one. There's no exponents in this one either. So we don't have to worry about the third step of exponents. But first, looking for any addition or subtraction. And you can see right here we have subtraction. So we're going to undo the subtraction by adding. And you can change this to plus and negative 3, but still it's negative 3. So we're going to add, I don't know why I said 3. We're going to add, why I said 5. We're going to add 3 to both sides. So by adding 3 to this side, that takes care of that. That's gone. Negative 3 plus 3 is 0. So we just have x plus 2 over here. Or sorry, x over 2. But we got to add 3 over here as well, and that would make us have 8. So 8 is equal to x divided by 2. Now let's undo any multiplication or division, and we have division. So how do we undo division? We multiply by, so it's dividing by 2, we're going to undo it by multiplying by 2, or 2 over 1. Okay, because that'll take care of the 2's. 2 over 2 is just 1, so it cancels out. So now we're left with on the right side x over 1, which is the same thing as x. And we have to do that over here, multiply this by 2, or 2 over 1. And 2 times 8 is 16, or 16 over 1. But it's the same thing. So we have x is equal to 16. And now remember, we can always check these, and whether it's a mental check or an actual physically plugging it back in, plug in 6 for x to see if it makes sense. Is 2 times 6 plus 3 equal to 15? Well, 2 times 6 is 12. You add 3 to that, you get 15. So that one worked. Same thing here. Plug this in. Would 16 divided by 2 and then adding a negative 3 be equal to 5? Well, 16 divided by 2 is 8. Minus 3 would get you to 5. So that one is good as well. Now, there is one exception. And that would be a problem like this. And I'll write it to get it a little bigger here. X minus 7 divided by 3 equals negative 12. What do you notice about that? You might notice that the left side is just all one division problem. You have subtraction on top of the division problem, though, or on top of the fraction. So it's a little bit different. In this case, we're going to undo the division by multiplying each side by the denominator first. Since the left side looks like it's just all division, I know there's subtraction, but it's part of the division. We have to get rid of the division first. Okay? So a problem like this, and you'll see problems like this, just know that we're going to get rid of the division first. So getting rid of the dividing by 3, we're going to multiply by 3. Or by 3 over 1, then we're going to multiply by 3 over here, because that will cancel out the division. Then we have just a simple x minus 7. And negative 12 times 3 is negative 36. So again, 12 times 3, that's 2 times 3 is 6. And 1 times 3 is 3. That's where I got the 36. And with a negative, we put the negative there. Alright, and then last step is to get the x by itself, and we just can get rid of the subtraction by adding 7 to both sides. X is equal to negative 36 plus 7. So we are at negative 36. We're going towards 0. So we're going to get negative 29 is our x value. And again, with that, you can plug that in and check it as well. It'll work out. But that's the one exception to the rule. So make sure you have an example of each of those. And can reproduce it on your own. I do have one last problem that I'd like you to think about. See if you can figure it out. The hard part is writing an equation for it. The easy part, hopefully, will be solving it, since we've just worked on solving it. But it says community service. You are making a bulletin board to advertise community service opportunities in your town. So maybe you are big into community service. You plan to use half a sheet of construction paper for each ad. So it's half a sheet per ad. You need 5 sheets of construction paper for the title banner, so the big banner. You have 18 sheets total. How many ads can you make? Well, we have 18 sheets total, so whatever we do has to be equal to 18. And all the paper that we're using, well, we're using half a sheet, so one half we'll use X for a sheet of paper. Half a sheet, half of an X per ad, plus we have to use 5 of them on the banner. So there's our equation. One half of each sheet plus 5 sheets should equal 18, and you can use that then to solve. So I'm going to leave that to you to solve. It's a 2-step equation. And once you've solved that, think back to our learning target for today. Being able to solve 2-step equations for one variable. That's the goal here. That's the target. Can you do it? Have a great rest of your day.